So today we're going to be going over Chapter 6, Lesson 3, Solving Quadratic Equations by Factoring. So what we're going to learn is how to solve quadratic equations by factoring and how to write a quadratic equation given two roots. How is the zero product property used in geometry? The length of a rectangle is 5 inches more than its width, and the area of the rectangle is 25 square inches. Find the dimensions of the rectangle you need to solve the equation. X times quantity x plus 5 equals 24, or x squared plus 5x equals 24. And so if we know that length times width equals the area, which is 24, and we know that if this side is x and this side has to be 5 inches more, this represents our situation here. And so this would be an example of an equation that we could set up in order to find out what this length has to be. So solving equations by factoring. In the last lesson, we learned how to solve a quadratic equation like the one above by graphing. Another way to solve this equation is by factoring. So let's consider the following products. Notice that in each case, at least one of the factors is zero. These examples illustrate the zero product property rule. So for example, if you, for any real number, a and b, if a times b equals zero, then either a has to be zero or b has to be zero, or both a and b have to be zero. And so what that breaks down to is whenever you're multiplying two things, right, the product of two things is if it equals zero, the only way to multiply and get an answer of zero is if one of those two things is zero, right? Because the only way to multiply and get an answer of zero is by multiplying by zero. So either this quantity has to be zero or this quantity has to be zero. So what that allows us to do is use that zero product property rule to state that, well, either x plus 5 had to be equal to 0 or x minus 7 had to equal to 0. And so let's look at how we can use this to solve a couple of quadratic equations here. So we have two problems here. So let's solve the first one. So we have x squared equals 6x. So that is a quadratic equation because we have x squared there. So the first thing we want to do is we want to set it equal to 0, right? So we want to get everything on one side of the equation. So we're going to start off by subtracting 6x from each side. And so now we have x squared minus 6x equals 0. So now that we have the equation set equal to 0, now we can go ahead and factor this part. So if you notice, it's only two terms. So we can see that both terms have an x in common. So we can factor out the x. So x times quantity x minus x equals 0. So now I have a product here. I have x times x minus 6, right? I have this times this. If this times this equals 0, well, that tells me that either x has to be 0 or x minus 6 has to be 0. So now I can go ahead and solve these because now I just have two equations to solve. The one on the left, x equals 0, is already solved. The one on the right, I have to add 6 to both sides, and it would tell me that x has to equal 6. So now I know that the solution is either that x is 0 or x is 6. And you can check to see if those two things actually work, right? We can substitute 0 and 6 into x into the original equation and see if it actually works. So if I take the original equation, substitute 0 in, right? 0 squared is 0. 6 times 0 is 0. 0 equals 0. Let's go ahead and test the other solution, 6. If I substitute 6 in for x, 6 squared is 36, and 6 times 6 is also 36. So that also works. So those would be my two solutions, 0 and 6, as I stated up here. Let's go ahead and take a look at the second example here. So here I have 2x squared plus 7x equals 15. So again, what am I going to do? I'm going to take this original equation. I'm going to set it equal to 0. So I have to start by setting everything on one side of the equation equal to 0. So I'm going to start by subtracting 15 from each side. And so I have 2x squared plus 7x minus 15 equals 0. And then I can go ahead and factor. So you have to use your factoring techniques that we learned previously from previous chapters. And so this factors out into 2x minus 3 times x plus 5. And now I can see that I have a product of two things here equaling 0. So 2x minus 3 has to be 0 or x plus 5 has to be 0, right? Because if this times this equals 0, either this has to be 0 or this has to be 0. So now I have two equations that I can solve. So let's go ahead and solve them. So I would add 3 to both sides, divide by 2, which gives me x equals 3 halves. Here I'd subtract 5 from both sides, and I get x equals -5. So now I know my solution occurs at -5 and +3/2. Those are my two answers. Again, you could substitute these back into the equation to test it and make sure that they work. So we are going to go now talk about this thing called the double root. So let's look at this example here. I have x squared minus 16x plus 64 equals 0, and I want to solve by factoring. So again, I'm going to take this original equation, I'm going to factor it. So again, if I factor this, I have to use my factoring techniques, right? So this is going to be x minus 8 times x minus 8. And again, you can multiply these out, and it would show you that you could go back this way. So now that I've factored it, I have this times this equals 0. So either this parentheses has to equal 0 or this parentheses has to equal 0, right? So if I set each one equal to 0, again, I'm going to solve this one by adding 8 to both sides. Same thing here. And if you notice, you get the same answer twice. So that's why it's called a double root, because it in fact only crosses the x-intercept at 8. So this double root tells me that since it only crosses at 8, that's where the vertex is going to be. So here the solution is 8. And the reason why it's called a double root is because you get the same answer twice. So when we talk about double roots here, the application of the zero product property produced two identical equations, right? X minus 8 equals 0, which both have a root of 8. So for this reason, 8 is called a double root of the equation. So again, we can check a graph, right? So if we were to graph this function, it would give us this parabola here, and you could see that the vertex occurs right at 8, 0. It only crosses the x-axis one time. It only has one x-intercept, and it's right at the vertex. That's why this root comes up twice, because it's the exact same one from both directions. Let's look at number 3. It says solve 3x squared minus 3x minus 60 equals 0 by factoring. So again, we want to factor it. So you have to use your factoring techniques. Now I notice that all three of these terms are all, I can factor 3 out of all of them. So I'm going to do that. So that's going to leave me with 3 times quantity x squared minus x minus 20 equals 0. Now I can divide 3 on both sides to get rid of this 3, and it would just give me x squared minus x minus 20 equals 0. And then I can go ahead and factor this again. So again, using my basic factoring techniques, I could factor this into x plus 4 times x minus 5. So if this times this equals 0, then again, we can go ahead and assume that either x plus 4 has to be 0 or x minus 5 has to be 0. And I would go ahead and solve each one, and I would get that x equals -4 or x equals 5. So that would be my solution set. My solution set would be -4 and 5. Those would be my two answers. We can also write quadratic equations. You have seen that a quadratic equation in the form of quantity x minus p times the quantity x minus q equals 0 has the roots at p and q, right? These two numbers end up being your roots. You can use this pattern to find a quadratic equation for a given pair of roots. So let's look at this example. It says write an equation given roots. So write an equation with 1/2 and -5 as its roots. Write the equation in the form ax squared plus bx plus c equals 0, where a, b, and c are integers. So again, we can go ahead and take this based off what we know. We're basically working the problem backwards. Typically, we end with something that's factored and use a zero product property rule to figure out the answer. But here, they're telling us what the roots are, right? They're telling us what our solutions are. So I can take these two values and put them in for p and q. So I'm going to go ahead and do that, right? P, I'm going to put in 1/2. Q, I'm going to put in -5. And notice these double negatives here. That's just going to simplify to positive, right? So I have x minus 1/2 times x plus 5 equals 0. And now I can just use the FOILing method and multiply these two parentheses together to make sure I get it into this standard form here. So x times x is x squared. X times 5 is 5x. And then -1/2 times x is -1/2 x. And then -1/2 times 5 is 5/2. And then when you combine like terms, it gives you x squared plus 9/2 x minus 5/2 equals 0. And so this would be our equation in standard form. We could also continue to simplify if we wanted to have it did say that a, b, and c needed to be integers. So if we multiplied the whole equation by 2, then you would get 2x squared plus 9x minus 5 equals 0. So that just makes it so we make sure to have all integers, because I forgot about this part right here. So now we have all integers there, no more fractions. So again, writing an equation, remembering the pattern that x minus p and x minus q equals 0 produces one equation with roots at p and q. In fact, there are an infinite number of equations that have the same roots. Thank you guys for watching. Let me know if you guys have any questions.